When given an equation in standard form and asked to solve, sometimes factoring will work, but the quadratic formula will always work. So it is possible to solve by factoring. Sometimes I think that's easier. For example, trinomial where leading coefficient is 1, that's guess and check, listing out the factors using different signs to get a positive 2. It's x minus 2, x plus 4. Set each part equal to 0. You get positive 2, negative 4. I feel like that's pretty straightforward. That's easy. If factoring works, that's wonderful. Just so you know, this is the same equation where a is 1, b is 2, c is negative 8. I'll show you that the quadratic formula also would have worked. So negative b plus or minus square root b squared minus 4 times a times c all over 2 times a. That gives me negative 2 plus or minus square root of 2 squared minus 4 times 1 times negative 8 gives me 36. Square root of 36 is 6. And then because these are like terms, I can branch it off. That plus or minus only belongs to the 6. So it's only signs that are changing. That gives me 4 over 2, which is 2. That gives me negative 8 over 2, which is negative 4. So you'll notice 2, negative 4, 2, negative 4. This was a lot more work, but it did work. This is easier, I feel. So just to show you, once again, factoring, love it if it works. There is a GCF here of 3. Don't forget to be checking for a GCF. Dividing each term by 3 gives me x squared minus 2x plus 1. This is guess and check. Factors of 1 using same signs to get negative 1 is x minus 1, x minus 1. Set each part equal to 0. This does not give me anything. This gives me positive 1. This also gives me positive 1, which is the same number. So you could just list 1 once. This one, just to show you, if you were to do the quadratic formula, a is 3, b is negative 6, c is 3, x equals negative b plus or minus square root b squared minus 4ac all over 2 times a. Negative negative makes a positive. Make sure you're plugging your negative 6 in parentheses. Minus 4 times 3 times 3. That gives me 0. Square root of 0 is totally fine. Guess what? Square root of 0? 0. It's gone. You just get 6 divided by 6. It's 1. So that's not too bad for the quadratic formula. So what I'm trying to show you here is factoring. If it works, then that's awesome. Let's go for it. Quadratic formula will always work. So if I'm taking a look here, there's no GCF. So a is not 1. I'm going to have to multiply first and last term and then list out the factors of 32. Now, using different signs, which pair gives me negative 1 when they add? They don't. This one is not factorable. So for this one, factoring fails. You can't use this method. You have to then use the quadratic formula. So just because factoring fails doesn't mean there's no solution. There is. You just have to use a different method. So a is 4, b is negative 1, c is negative 8. Let's plug it in. X equals negative b plus or minus square root b squared minus 4ac all over 2 times a. 2 negatives makes a positive 1 plus or minus square root negative 1 squared minus 4 times negative 8 gives me 129 all over 8. 129 has the factors 1, 129, 3, and 43. No perfect scores other than 1, so that's the answer. So not a super nice answer, but it's an answer. If I were to do this one, leading coefficient is negative. If I'm trying factoring, I do have to pull out that negative GCF. Dividing each term by negative 1 gives me this. Multiplying first and last term, 99 are 1 and 99, 3 and 33, and then 9 and 11. Using different signs to add to 6, not possible. But again, just because it's not factorable doesn't mean it doesn't work. we're just going to have to do the quadratic formula. So it's okay. You don't have to pull out a GCF or anything like that. If you're not factoring, if you're just doing the quadratic formula, you just label A, B, and C and plug it right in. It's a plug and chug. So negative B plus or minus square root B squared minus 4 times A times C all over 2 times A. That gives me negative 6 plus or minus the square root of 6 squared minus 4 times negative 9 times 11. It's 432 over negative 18. Now, 432 has multiple perfect squares in this list of factors. Just so you know, the biggest perfect square is going to be 144. So the square root of 144 is 12. Square root of 3 doesn't simplify. That gives me negative 6 plus or minus 12 root 3 over negative 18. So what we're going to do is we are going to separate our terms. I know this is going to look a little weird, but this does simplify. So negative 6 over negative 18 plus or minus 12 over negative 18 root 3. Both of these are divisible by 6, and 2 negatives makes a positive, so it's positive 1/3 plus or minus. Both of these are divisible 6, so 2 root 3, 6. This is not a like term, that root 3, so you can't simplify. Oops, I meant to put a 3 there. So that would be the final answer.